Hey everybody, it's Ripley again. We're going to go ahead and finish up the material in Chapter 1, just to give you an idea. Again, this is going to be real heavy vocab-wise, so you might want to make some flashcards. You might want to revisit it. Remember, your textbook is a great resource that you can carry with you wherever you go, in absence of a Wi-Fi connection, if you can't get access to this video again. Okay? All right, but today we're going to start collecting some data. It's going to collect data. We're going to talk about the ways to do this. Okay. Now, I apologize for my rudimentary drawing, but if I would rather saw my foot off with a spoon than make another PowerPoint. Plus, I think it's more interesting to talk about it this way. Let's talk about the different ways that statisticians and scientists collect data and why they collect data. All right. First and foremost, there are two types of tools that statisticians use and that scientists use when they want to try and prove something with statistics. All right? First and foremost, there's something called an observational study. All right? Observational study is simply just an observation of past data. So we're looking at past data. It would be things like number of troops that were killed in the war in Afghanistan or the war in Iraq. It would be the average GPA of the class of 2012. Things of that nature. You're just observing. You're not doing anything at all. You're just looking at it and you're writing down the numbers, and then we do mathematical analysis on that. And I'm going to show you what that mathematical analysis entails. Now, I don't mean to present this as being a weaker thing to do numerically. It's just different. All right? The other is to do an experiment. All right? Now, let me tell you what an experiment involves, because experiments are really cool. An experiment simply involves, sorry about that, my pen's a little squishy, it simply involves a treatment. All right? And at its absolute simplest, let's do this first. I'm going to have one group, so this is sample A. All right? So I take a sample out of the population. Remember how that works. If this is the population, which is the set of all things that have a certain measurable characteristic, then what I do is I take a little group out of that, and this right here becomes my sample. Now, the way in which we grab that sample is really, really important. We'll go into that. We'll go into the best practices for that here shortly. But let me show you what happens back over here. All right, so here's the way an experiment works. So I've got sample A, and then I got sample B. All right, and sample A is just your rank and file. Let's call it my control group. So we'll call these guys the control. And really, with the control group, what that implies is we do nothing. We just leave them alone. So do nothing. Let them do what they're going to do. Okay? And then with the experimental group, what we do is we apply the treatment to them. All right? And then we measure for differences. So, for example, let's say that we want to measure the effect of loud music on performance on an exam. Okay? So I would come over to my population of students taking a statistics exam. I would pull out a sample that would become my control group. I would pull out a sample that would become my treatment group, and then I would give them an exam. All right, the control group would be sitting in a room, a nice quiet room, standard issue. The treatment group would be sitting in a room with loud music playing. So there'd just be this god-awful, loud, whoops, lost my thingy. I'm terrible at drawing these, sorry. Loud music. And then what I would do is I would look at the effect that had on the performance on the exam. The control group, I'd take the average or whatever. I could do it graphically. We'll explain that down the road. Look at their average. I could look at the treatment group's average on the exam, and then I look for differences. Now, I think that we all intuitively think that the treatment group may do poorly, but you never can tell. And that's where we start getting into a lot of the more nuanced things that deal with statistical analysis. Okay? Now, like I said, I don't like to do PowerPoints. However, that said, we're launching into a vocabulary situation here, so I'm going to put some stuff up on a PowerPoint as well, just so we can blow through the vocab real quick, and it just makes it easier than having you sit there and have me write simple, random, sample. All right, which my handwriting is terrible. So bear with me. The PowerPoint will pop up here in just a sec, and you can enjoy that. And flash! We're in a PowerPoint production. Sorry about that, you guys. Okay, so let's talk about data collection and how to build your samples. There are three basic random samples that we have to think about here. The first is a simple random sample. The simple random sample, let me see if I can explain this. Let's say that I gather a sample of 5 kids to create a sample that I'm going to do an experiment on. Simple random sample says that that group of 5 kids, again, let's go with gifted kids, okay? That group of 5 kids has the exact same probability of being my sample as any other group of 5 kids. So it's the sample that is randomized. It's not the individual. So if I were to take one member out of the 5 kids and stick a different member in, that group of 5 kids has exactly the same probability of making it as my sample. All right? Now that's different from a random sample. In a random sample, every individual in the population has the exact same probability of being chosen to be part of the sample. There's a distinction there. Think of the simple random sample as the sample is what's being randomized versus just a random sample where the individual is being randomized. Then there's something called a probability sample. That's where each individual in the population has a probability which is known, but it's not necessarily the same probability for every individual in the group. And the reason we do stuff like that is, let's say that I'm trying to test some gifted kids, okay? And I know that my gifted population is 10% African American, 20% Asian, 50% Pacific Islander, and the rest are Caucasian. Then what I want to do is, I don't want to do a simple random sample with that, because if I'm trying to grab 5 kids, I might end up with 5 Caucasian kids, or I might end up with 5 African American kids, and I want my sample to reflect my population. So what I would do is I would tweak the probabilities that the Caucasians would get in, so that their probability of getting into the sample reflects what proportion of the population they truly are. All right, so just so you know. All right, other methods of sampling. Now let's talk about these. Some of these are good and some of these are bad. So we'll yap about them just a little bit here. Now there's systematic sampling. Systematic sampling, think of it this way. If I'm trying to sample the population of the United States, and I happen to have all their Social Security numbers, so I work for the Social Security Administration, and I'm just trying to get some information out there. And clearly maybe it's a pain in the butt for me to be able to try and completely randomize this. So what I do is I take my list of Social Security numbers, and I'm going to grab every 20th person. Okay? Well, clearly that's not a truly random sample, because every person doesn't have the same probability of getting in. But it's a real systematic way for me to gather data. Okay, that's systematic sampling. Convenient sampling, probably the worst of the sampling. I wrote it as the man on the corner. That's where you stand outside of your house and you gather data from people that come walking by you. Now, as you can probably tell, that's going to be a little bit biased, because the people that come by you are your neighbors, so they probably share, at least your socioeconomic status. They might share a lot of the same data that you're trying to gather. So that's a great way to create bias, not a wonderful way to sample. There's stratified sampling. Now, stratified sampling is kind of cool. This is where you take the population and you break it up into groups based on characteristics, and then we select those. Now, let me see if I can get this thing to work right here. I'm going to grab my ballpoint pen. Now, think about it this way. If I take all of the Think classes, and let's say that there are 4 Think classes, and I'm going on at any time. So you got the stat, and you got the history, and you've got the English, and then what else? You got the philosophy. So I'm going to break these guys up by class. I'm stratifying them based on classes. And then what I do is I grab a couple of people from here, a couple of people from here, a couple of people from here, and a couple of people from here. That's how stratified sampling works. So you bust them up into their strata, and then that guarantees that you have representation from each one of those strata. That's another way that we could do in that little race sample that I was talking to you guys about earlier. Excuse me. You could say I'm going to bust them up based on race. So you'd have your Caucasians, you'd have your Asians, you'd have your Pacific Islanders, your Caucasians, etc. Now cluster works the same way, except what we would do is we would say we're going to bust all of the classes up, and then we're going to randomly select one of these classes to be our sample. So we're going to take the entire group, and that becomes our sample. So rather than 2 from each one of the classes, we're going to take all 8 out of the stats class. Or we may take the entire stat class if the stat class happens to be 8. Okay? So those are other methods of sampling, some of which are pretty good and some of which